Hello, Professor. Welcome to Hu's Proj.2 Demonstration 2. So let's begin with the demo of the app. As you can see in the screen, this is the projector of my cell phone to the computer, and this is the edge. It's obvious there is the red line for detect the edge. And so let's try the best lines. There is the best lines. As you can see, the half line in horizontal is blue, and the half line in vertical is red, and that vertical line is within 30 degrees. And if I try to make the cell phone inverted, as you can see, there is no longer any red lines because they are more than 30 degrees, but there are blue lines. So that is the part of demo of the app. So let's see the code. The code here is as we call something from the main activity as shown in here. Add a case called edge and call the function called my edge2, and make a case called best line and call the function my best lines 2. And let's go through this method. As you can see, I create a new class called my algorithm, and those methods about edge and the best lines is in there. There is a class overview about the class. As you can see, I use the compiler is Android Studio 2.3.1, and the main Android SDK version is Android 5.0. But the target Android SDK version is Android 7.1, and the OpenCV version is 3.1.0. And let's begin with to see the edge. There is a previous edge just called the OpenCV method in a double for loop, and this is quite slow because there are a million JNI calls in one frame, and it takes about 20 seconds to execute one frame. But I rewrite the idea to make less call in the new edge, as is written in the comments. It says implement in Java calling just O1 JNI calls rather than calling O times hit JNI calls. The method about edge is as shown. The first thing is to make the input as a color input, and we create a new gray mat and convert the color input into gray. And these things is about to convert the mat into the array, and once it's into our array, we can manipulate with the mat in Java rather than call the C++ library. And so there are double for to iterate through pixels to pixels, and there is a function call called Laplacian2, and the parameter is gray array, which has been get here, and the row column and the width, the height. What does this function do? This function is here. This function is about to do the Laplacian transformation for the array, and you see there is a gray total here, and we need to calculate the half of the kernel size. What is the kernel of Laplacian? Well, it's defined on the top of the class, there is a private static final int array called the kernel of Laplacian, and is 0, 1, 0, 1 minus 4, 1, 0, 1, 0, which is a positive Laplacian transformation. Let's go back to the code. As you can see here, I iterate the pixel around it and make a Laplacian transformation, and I add them together and return these points Laplacian value. And once the value is returned, let's make a comparison with the thresh value. If it's bigger than the thresh value, then it seems to have a threshold transformation, but in the MyEdge it doesn't need to store it actually. So we just say if the Laplacian value is greater than the thresh value, then we change that color to the red, and you see there is a color array. This color array is also here, has been transformed into the array, and we change that point to red, and that is just to I see is Laplacian transformed, and once O is greater than thresh value, then I change the color matte point to red. And after I finish all this, I will say, put the color array into the result matte, and convert the result matte to the CV8 unsigned int. Probably it should be byte, and return the result. So that is about MyEdge. And let's go through my best lines. As you can see, there are also another best lines here, and this is also slow because the same reason, because a million JNI calls, and is also slow. So I just change it, and in this case, the same trick is also we need an array, but for this time we need a Laplacian array to store the result after Laplacian transformation and threshold. So this is about how to transform a matte into an array. And this part is iterate through pixels to pixels. And what we do is, the first thing is make the Laplacian transformation. And once the Laplacian transformation value is greater than the thresh value, then we do the threshold. If the value is greater than the thresh value, then we say is 255. Other is 0. So this sentence can treat as do a threshold, and we store it in the Laplacian array. And this time, after we have the Laplacian array, we put the Laplacian array into the Laplacian matte and convert it to the 8-bit unsigned. And then we call a function is called draw half lines. The draw half lines is just call it, and you can see the threshold line is the minimum row or column, and then over 4. And we call the OpenCV APIs half lines, and the parameter is as you required, and we just iterate the half lines and say we want to draw the point. First job is to calculate the point, and once we have 2 points, we can calculate the slope, as you see in the comments. And once the slope, actually this slope is the tangent degree, and if once the tangent degree is less equal than the tangent 30 degrees, and we can say, this line is we needed to put it into the array list for further sorting, and we create a line information. What is line information? Actually, this is another class. As you can see the class overview, this is a data storage class, and it stores 2 points that can exactly draw a half line. So there are 3 class variables. One is save the point 1 and point 2, and we save the length. Actually, this is not the length, this is the length square. As you can see, we calculate here, that is point 1 minus point 2 and square, and then plus point 1 minus point 2 square, and this is a square of the length. But we will calculate we will sorting all the information by the length square. And as you can see, I also implement a comparable line information and override a method compare to. And as the comment says, sort this class by variable length in descending order. This makes it sense. And further, I will call collections.sort and this list to sort directly. Let's go back to the algorithm, and we just create a new info and put it into a list. This list is declared as a class variable at the front. As you can see, this is private list information, line information list. And in the constructor, I declare this list is an array list, but maybe it can change, depends on other situations. I can change it to linked list or other list, whatever. It doesn't really matter. So let's go back to the code. As you can see, if it is within the 30 degrees, then we store it into list, and after store it, we have to draw every half line. That is about the draw half lines. So let's go back to the best lines. After we call the draw half line, we will draw the best 10 lines. So let's go to draw best 10 lines. The first thing is that we sort the list, and we will draw at most 10 lines, which 10 or the size of the list, which smaller. That is in case we will go index out of bound and it will have a null pointer exception. And we just iterate and draw the lines, use the image proc.lines to draw it. As we draw it into the destination mat, and just say get that information, and get point 1, get point 2, and the color here is red. And after we draw it, we clear the list, because each frame have a lot of half lines. If we don't clear it, there will be old half lines in vertical will just in the list, and that is what we don't want to see. And back to the code, after we draw the best 10 lines, and we can return the result as it is truly put on the frame. So that is about the code. Well, for the implementations, I have implemented all the things you required in Proj.2. But although I have also improved the algorithm, make an improvement in the GNI course, there still are few things to do to keep improving my code, such as in my best lines, I can reset the result mat to make it smaller, and in this case it will be faster, because as you can see in the Android monitor, well, Where is it? You can see the edge execute time is about 140 milliseconds, and the FPS meter set is only 5.93 FPS. So it's still slow, not smooth enough. So in my point of view, if the further improvement is about to resize the input and make the calculation smaller, because for now the resolution is 1280 times 920 720, so it's a big picture. The further things I will to resize it and manipulate on a smaller picture, then resize it to the original resolution and the output. That will make the calculation easier, and the execute time will be faster. And that is all about the Proj.2's demonstration tool. Thank you for listening, Professor. See you.